everybody. Good day, and welcome to our fourth public Global R&D meeting. This is actually the October meeting, although we're in November. And the reason for that is that for the rest of the year, we are shifting to like a 3-week cadence, so we don't have to have like a Global R&D meeting during our Christmas break. I'm delighted to have once more a very exciting agenda. We have a few updates, like always. We discuss some features, and actually we have a record number of 5 demos today. So let's get at it and see what updates we have for you. So we can start from that. So the last couple of times we had like a few slides about the roadmap, explaining how the roadmap looks and so on and so forth. This time we just want to present some highlights and rather refer people to the roadmap on the internetcomputer.org. You see the URL right there. And I guess one of the highlights is that now all the accepted motion proposals are actually featuring on that roadmap. And we also want to, I guess, increase how we work with the community on shaping that roadmap. We won't talk too much about that right now, but just want to mention that actually the II canisters have moved subnet, so they're no longer hosted on the NNS subnet, but on a dedicated subnet. Hopefully nobody really noticed too much of that, just that the II canister was unavailable for a bit. If you go behind the scenes, that was actually a huge amount of work and was far from trivial. So thanks and congratulations to all the II movers, those you see in the picture, and a bunch of other people as well. Another highlight is that now canisters have 32 gigabytes of stable memory available. So I hope that makes a bunch of people very happy. Yeah, please have a look at the roadmap on the website, and let's go to the next slide. Talking about the website, you might have seen that the website has changed quite a bit, and we're currently constantly working on that, and you will see many improvements on the website. And the website, in some sense, is the tip of the iceberg for shift in the foundation, in R&D, and in those other parts of the foundation. Namely, because so far the foundation has very much focused on building the intercomputer and building the best blockchain in the world. And we all know that the ICP is great. That's why we're all here. But the shift is that we also need to let it be known to the rest of the world. And of course, like the website and the documentation on the website is a big part of that. So we'll put more work into that. And but also, I think this is also a call to the community, but please help spread the word here, because, I mean, after all, we are all together in this, and we want to make the intercomputer great and let that known. And the foundation is just one of the stakeholders of that. So there's many more stakeholders, and we really want to engage with the stakeholders and I think encourage everybody to spread that word. So also you can provide feedback and actually contribute to the website. The website and the wiki, it's all publicly accessible. There's on GitHub, you can either enter pull request to suggest changes to text on the website. And as we speak, we are also trying to open up the things so to make it even easier to contribute there. So for instance, like the part of the website that has community projects listed. So we want to make it easier for other projects to be featured there, so they could just add themselves. So this time is more like a teaser to be continued, and we really want this to be a shift of the focus for R&D and the rest of DFINITY. We need to sell the internet computer. And as part of that, we are also going out to the world, and Ricardo has some exciting news about that.
Thanks, Jan. Nice to meet you all. This is Ricardo. I'm the Chief of Staff at DFINITY. Global Marketing is the youngest sibling of Global R&D. So we're happy to be hosted here and present coming initiatives, especially from the Token 2049. Dominic William will be speaking at Token 2049 in London after the successful Token 2049 in Singapore. He will deliver a keynote speech on the 10th of November, and also a panel with other layer ones in the afternoon of the 10th of November. But on the 9th of November, we're organizing a celebration for the technical future, technical achievements, and most importantly, the project's achievement. So all about the ICP projects, partners, and VCs. And we're doing that in London at Canary Wharf. Next, please. The ICP projects in London that we will invite are Shiku, Pocket Studio, OpenChat, Discover, Canistore, Infinity Swap, Yumi, Code and State, Origin, and Crowdfund NFT. And we're very excited because all of the founders and the executive teams of this incredible ICP projects will be in London. Next, please. We've also had the opportunity to partner up with VCs and partners such as Tomahawk, Warburg Series, and Boxler, but also Off-Chain and Crypto Mondays that are also collaborating with the foundation and with the community to organize a number of interesting meetups, events, and parties all over the world. Next, please. If you guys are going to be in London, you don't need to get a ticket at Token 2049, but you can come and meet us at the Rocket in Canary Wharf on November 9. The team will be composed by both team members coming from the Zurich headquarters, like Dom, Jan, myself, Andrew, and Maurice. Team members coming from the US and also from Asia. So Lomesh and Herbert will join us. And then we have an incredible group of special projects marketing contractor. And I have Minde, Clement, Shruti, and Jesse coming from all over the world. Thank you, and back to you, Jan.
Thanks, Ricardo. Looking forward to meet many, many people of the community and otherwise in London next week. So one way to sell the internet computer, of course, is to compare it to other blockchains. And I mean, did you know that the internet computer is greener than any other blockchain and even greener than cloud providers? So Aisling has all the details here. Take it away.
Thanks a lot, Jan. So yeah, I'm Aisling. I'm a researcher here at DFINITY, and for the past while, we were working a bit on the sustainability report. It was actually, there were some teasers in a previous Global R&D, so this is a bit of a follow-up now to show you how did we measure overall in the final report, what were the key results, and to sketch some of the follow-up activities. So if we go to the next slide, please. I thought it was important to actually take a second to say, why should we care about this? Because I guess for me and for Jesse and for the Carbon Crowd guys, it's like, yes, we absolutely need to care about this. We are doing really well. But maybe that's not the case for everybody. And I think one thing that is the case for everybody is that we kind of generally all agree and know that blockchains have been considered to be a climate disaster. And this was often boiled down to Bitcoin and its proof of work mechanism kind of burning as much electricity as Argentina. So this was always the kind of headline, and it gave blockchains in general a bad name. And then the conversation moved a bit to, okay, maybe this is the proof of work thing. Actually, if we move to proof of stake, maybe it's a lot better. But that's kind of looking backwards. If we look a bit forwards, we want to build a world computer, and this must be sustainable, because if we have a machine that is decentralized, there's no single point of trust. If we have scalability, energy efficiency, all of this, you really need to kind of provide sustainability on a very different level to what is seen either before in the past or what exists today. This is something that we claim to achieve, actually. It's something that was kind of baked into the design of the internet computer. And so now with this report, one of our main motivations was to establish the facts on the ground. Actually, have we achieved this? Have we, like, are we the kind of greenest, most energy efficient, usable blockchain? And also, a nice consequence is that this turned out to be a motion proposal, which was requested by the community, in specific ICP Jesse. And also in parallel, Carbon Crowd were working on various sustainability technologies where they needed the carbon footprint as well. So there were kind of many things we wanted to show, how are we doing? And the community also wanted to see. So we all kind of joined together to produce this report. So if we go to the next slide, we see how do we actually measure. There are two kind of main results in the report. One is about the energy consumption, where we measure the actual energy consumption of the nodes. We basically have a kind of reading from 1 out of every 2 subnets that run the internet computer. So from this, we kind of extrapolate to all nodes and get a reading for how much energy the internet computer uses right now. Overall, annually, it's less than 100 US households, so it's pretty low. The second main result was that we then took this energy consumption and together with Carbon Crowd, calculated the carbon footprint of the internet computer. And to get the carbon footprint, you take the emissions, you weight the average of the nodes by the emissions factor based on where they are geographically located. And overall, we burn 275 tons of CO2 per year. If you want to sort of measure this in your mind, what does this mean? You can think of 1 ton of CO2 is like a return flight from Paris to New York, or overall 275 tons. What it takes to run the internet computer per year is about 1.5 rail cars worth of coal. So if we go to the next slide, I think it's my favorite. So here we see the comparison against other chains. And this comparison we present in terms of transactions. So the energy consumption it takes per transaction. And here you can see that we have to even zoom in between DIC and the next best. And this is because the next best is 25 times larger than the internet computer. And overall, we're 6,000 times lower than Cardano, this is the kind of group of proof of stake-like blockchains, let's say. And one question we often get asked is, why is Bitcoin not on this? I mean, we always try to compare against Bitcoin. And if we go to the next slide, we see that actually it doesn't really make sense to compare against Bitcoin because everything is out of scope. And overall, the internet computer is 350 million times lower than Bitcoin per transaction. So I think this actually kind of proves our hypothesis, let's say at the beginning. One is that, yes, proof of work and proof of stake are vastly different things to measure. And even within the proof of stake world, there are quite different levels of efficiency and sustainability that you can gain. And between both, the internet computer does extremely well. So we are really happy to see that the original goal and design intent of the internet computer has been achieved. And so if we go to the next slide, we can wrap up with some conclusions that, yes, we do deliver a fundamentally different level of carbon emissions that are substantially lower than anybody else. And the next step in the exploration are that we try to get real-time analytics on the dashboard. We want to establish green or carbon neutral subnets, and we want to establish a working group so that we can, this is the very start of, like, this is now the base level. And from here, we want to start building the conversation. So please get in touch with me or Carbon Crowd, Jesse, or anyone really, and let's continue with Valor. So that's all from me, and I pass it back to Jan. Thanks a lot.
Thank you, Ashley, and also huge thanks to Carbon Crowd. This is really great work. One area where the community is very active is certainly around motion proposals and about how to vote there, discussions, what this means. Yeah, I mean, personally, I love this activity. That this is really great, and I guess I regret that some of these discussions were maybe offended people, and some of them got heated. Hopefully, we can, some guidelines will emerge how we can have these discussions in a more structured way, and so on and so forth. I guess we also wanted to take the opportunity here to maybe explain some of the votes that the foundation did, because I think some of this got misunderstood. So Diego, please, over to you.
Hello, everyone. My name is Diego. I work in R&D, and I wrote recently a forum post explaining these 2 motion proposals, but I'll give a quick overview on these two. So there were two recent proposals recently, 80970 for spam prevention and 86639 temperature check for the NNS Treasury. Both of these proposals passed, and both DFINITY voted yes on. So both of these proposals led to a lot of debates and activity across many social channels, from the forum, Discover, District, Reddit, Tiger Network, Twitter, Discord, Telegram. So they've been really, really, really active. So I wanted to just we want to address them directly. Next slide, please. So there have been many schools of thought and many things around this, but I wanted to just kind of highlight the main things that we could all agree on. First of all, like Jan said, it is healthy that we all engage in open design discussions. I think that's very healthy. Two, we definitely should have been clear about our intent when we voted. So we wrote a long post explaining what our intention was, which can be simply summarized as: our intent was to support the spam proposal because we think it'll reduce spam, and it will not create any more ICPs, despite what some people thought. And two, for the NNS Treasury temperature check, our intent was to just not kill the conversation. We were not lending our support towards that design. We just wanted to let the conversation go. We should have been clear about both of these things. And we are actively listening for feedback from the community about how we can foster better dialogue, but also how we can communicate our intent more, and how we can involve the community. Lastly, I just want to point out one thing that we all agree on is that the temperature check proposal, which is one of the more controversial of the two, has no active. Even though the motion proposal passed, the proposal as we saw it was for just should the conversation continue. There is no design happening, there is no engineering happening, and there's no implementation that will happen. So I know people were afraid of that, but no, the proposal was just for whether the conversation should continue or not, and that's how we voted for it as well. Some people may disagree with that, totally reasonable, but most of all, we all agree on that nothing has been built for that proposal, even though it passed. Anyways, my Twitter is always open, as I know many people at DFINITY are, and we're actively listening. So please tweet at us, comment, use District, use Discover, use whatever to reach to us. We're actively listening to what we can do to improve. Thank you.
Thank you, Diego. And also at this point, huge thanks to you, Diego, for all the work you do with the community and explaining them on Twitter and so on and so forth. I guess you also see that from some of the replies you get from Twitter. So yeah, very helpful, Diego. Thanks a lot. Let's move on. We have a few features coming up next. The first one is a regular guest, namely, this is related to threshold ECDSA, Bitcoin integration, or coding Bitcoin, giving public keys and signing possibility to canisters. So we had some discussions around that last time, how we could increase the security here. And Andrea has some concrete steps that we're going to take next. Please take it away, Andrea.
Thanks a lot, Jan. Yeah, I'm Andrea from the crypto team, and I'm going to talk to you about rotation of IDKG encryption keys. So, as Jan said, this is about threshold ECDSA, and specifically is about increasing the security of threshold ECDSA protocol. And during the last Global R&D, we mentioned a few directions we wanted to explore to see ways we could improve the security of threshold ECDSA protocol. And since then, we looked into all the ones that we mentioned because we wanted to really see what we could concretely do. But we decided to focus on this key rotation mechanism that is this new feature that we are gonna work on. And the reason why we decided to focus on this is that, well, first of all, this gives us really something concrete. So it's really, an improvement with respect to the existing situation. But it also is something that we think we can release relatively soon, and so that it should not affect, the official release of threshold ECDSA. While for the other measures that are mentioned there in the slides, we either think that they do not give us immediately like a benefit, or they will take longer to implement. So we're not going to abandon this. We are going to pursue them in the next steps. But it's just that we are now focusing on key rotation, and that the rest will come next. Next slide, please. Okay, just as a quick recap, in threshold ECDSA, we need to set up a ECDSA key, and this is done by an interactive distributed key generation protocol, or ADKG. And this protocol uses threshold cryptography to set up this key in such a way that this key is not known by any single party, but this is secret shared between a set of nodes in the subnet. And the idea is that in order to be able to reconstruct the key, you need more than a third of the shares to be able to reconstruct it. And in fact, so the security of the protocol is guaranteed as long as an adversary cannot corrupt more than a third of the participants. Next slide. Yeah, so there were some concerns also in the community that an adversary may be eventually able to steal enough shares of the key and reconstruct it. And indeed, if we are thinking about a situation where keys are generated once and for all and never change, the adversary may have like a very long time to actually steal the state of the nodes and try to extract the signing share of the ECDSA key, and eventually collect enough and reconstruct the master signing key. So in order to improve this situation, we suggest a mechanism to essentially refresh these keys. Next slide, please. Yeah, so concretely what we suggest is really to essentially try to refresh these keys. Of course, the ECDSA key we cannot change. I mean, we can generate new ones, but once we generate it, we need to keep it alive. But what we can do is to refresh the key share associated to the signing key. And we can do this by using the same protocol to use to generate the key in the first place, but in a resharing mode, which means the secret we are resharing in this protocol is a key that was already generated. It's not a fresh one. But the shares that we are generating are actually fresh and new. And the idea is that any set of these keys is just used for a limited amount of time. So we use a set of keys, we generate the new ones. When the new ones are generated, we discard the previous one and we move on. And essentially, all these key sets are only used for a limited amount of time. And how does this help? Next slide, please. Yeah, these helps out because an adversary that really wants to reconstruct the secret key. What it has to do is really to try to collect the shares, but the shares needs to come from the same resharing epoch. So the shares that are created here are really in various epochs are not really compatible with shares coming from other epochs. So an adversary cannot really mix and match keys here and hope to reconstruct the keys. So this really limits the time window that the adversary has to be able to reconstruct the keys from shares that he stores. And yeah, so these mechanisms that we need to refresh keys is a complex cryptographic protocol. But luckily for us, this is already implemented and we already actually use this in production. So the same protocol is actually used whenever a new node joins the ECDSA subnet. We run this protocol to give a share of the signing key to this new node. So the only thing that we need to do here really is to essentially trigger this resharing mechanism more often, so that an adversary has less time to possibly steal shares. Next slide, please. Right. So that's very nice, but we still have an issue that we need to address, which is that in this distributed key generation protocol, shares are communicated in the network, but of course these are not communicated in the clear. They are encrypted, and specifically they are encrypted using some long-term keys that the node has. So these keys are generated by the node, and they're used for a very long period of time, right? So what's the issue here? So an adversary here, even if you're doing resharing of the ECDSA key, what the adversary can do instead of stealing the share of the signing key, what you can do is try to steal the decryption keys of the nodes. And once he collects enough of those, then he can collect all the ciphertext and encrypt the shares for the node. Ciphertext coming for the same resharing epoch, decrypt them, reconstruct, extract the secret shares, reconstruct them, and then steal essentially the master signing. Next slide, please. So what are we doing to improve on this situation? What we can do is, similar as above, we introduce a mechanism for nodes to essentially rotate their encryption keys, so that an adversary doesn't have to just steal shares that are coming from the same resharing epoch. He also needs to be able to steal quickly enough the decryption keys that are currently used. Otherwise, he won't be able to use this key effectively. And luckily for us, this mechanism doesn't require any involved cryptographic protocol. It's just nodes can generate new keys from themselves and register them. So we only need to integrate a new mechanism for nodes to update their encryption keys. But this is not an involved protocol like in the case of resharing EKG. Next slide, please. Right. So just to recap, what we are really trying to do here is to increase the security of threshold ECDSA protocol. And specifically now we are focusing on this key rotation mechanism that we want to introduce. So this resharing of the ECDSA key, but also the rotation of encryption keys for the nodes. So we already started working on this actually, and we expect this to be out soon. So we really hope to get this done in November so that we can also stick to the main timeline for threshold ECDSA. And that's all I wanted to talk about. And back to you, Jan. Thanks.
Thank you, Andrea. As of recently, canisters have access to 32 gigabytes of stable memory. And now you might ask yourself, okay, is this 64 next? How can I use that stable memory? And so on and so forth. And here, Johan has all the answers for you. Please take it away.
Good evening, good day, good morning, wherever you are. Nice to meet you all virtually. My name is Johan Granström, Principal Engineer at DFINITY and old timer. And I'm going to talk to you about what DFINITY is doing in the big data space. So I will cover two topics. First is about a work that is ongoing to allow bigger and faster canisters on the internet computer. And the second topic is how to make a best use of this new data space and make canisters using data easier to use. Next slide, please. First, I wanted to make a distinction between a vertical and horizontal scaling. So we use the term a vertical scaling when we make a single canister more powerful, in this case, having more memory capacity. And horizontal scaling is about making it easier to write applications that make use of multiple collaborating canisters. Today, I'm only going to talk about vertical scaling. Next slide, please. To understand vertical scaling, we first have to look at how canisters store data. So in this picture, you see a canister on the left. It has a code and two memories, a main memory and stable memory. Main memory is at most 4 gigabytes in size, and it cannot grow further as it only has a 32-bit address space. And as everybody knows, 2 to the power of 32 is exactly 4 gigabytes. What's typically stored in this is a language or a compiler dependent data. That is a data that is in memory in a format that only the compiler is able to understand, which means that this memory must be cleared when the canister is upgraded, because the code, at least potentially, changes then. On the other hand, we have stable memory, which is, or at least it can be, a 64-bit memory, so it can, in principle, grow as much as anybody wants. And usually this is used to store data in a format that is independent of the compiler or programming a language, and this memory also survives upgrades. Next slide, please. To put things into perspective, in this slide, the circles have areas proportional to the amount of data that can be stored in the various places. So until, to begin with, 4 gigabyte is the memory limit of a main memory, and in a practice, it's often only practical to keep a bit less than that, because you also need space for saving and restoring from stable memory on upgrade and or for a garbage collection purposes. Until last month, the stable memory limit was 8 gigabytes, but it was increased to 32 gigabytes in October last month. And today, a host subnetwork can host around 350 gigabytes. And the long-term aspiration of the internet computer is that this number should grow over a time, eventually, hopefully reaching a terabyte and beyond. And the conclusion of this slide is that in order to take advantage of all this data, it's important to work on stable memory data structures. Next slide, please. So what's in it for developers? Well, obviously bigger and faster is what everybody wants. Vertical scaling makes it easier to manage, going from, say, 1,000 to 100,000 users. Eventually, you may need horizontal scaling anyway, but if you can grow in one canister, that's often much easier than having a multi-canister architecture. And having a faster access to stable memory will make it almost on a par with access to main memory. More about that in the next couple of slides. And now that we have, or will enable, a large-scale application to serve their data directly from stable memory, another benefit for developers is that they can avoid what we sometimes call upgrade hell, which is the issues in the save restore model. If you have data in a main memory, serialize it, and need to deserialize it again after the upgrade. If you keep the data always in stable memory, you avoid this issue completely. Next slide, please. So a little a detour here around why data matters. I put some quotes on this slide. I will not read them out, but I just wanted to say that thinking a bit more about data and maybe less about code can actually pay dividends in the long run. Next slide, please. So I began by saying that there were two topics, bigger and faster and easier to use. So in the bigger and faster space, we have seen some work happening already in September 2021, where this 64-bit interface to stable memory was introduced, and it was increased in capacity from 4 to 8 gigabytes. In October this year, it was further increased to 32 gigabytes, and we also had yesterday, I think, approved a motion to implement WebAssembly native stable memory, and this will eventually get implemented, and then stable memory can be increased further. Next slide, please. How to make a big data easier to use. It's a very big design space. In the interest of time, I will not say too much about this. And I think we need to go to the next slide because I'm already out of time. Last week, I published a forum post called Improving the Utility of Stable Memory. And I very much would like everybody's feedback on that and help us guide a direction of how to make stable memory easy to use on the internet computer in the future. This is the end of my presentation. I'm happy to answer questions either on the chat here or on the forum post. Thank you.
Thank you, Johan, for getting us excited about the future of stable memory on the internet computer. So we're moving on to our demos, and the first one is a regular guest. It's the service nervous system. And well, I can't read your minds, but on top of my mind is when SNS. So Pete, when SNS.
Thank you, Jan. This is Pete, head of product. So yes, I want to give you a quick update on where we are with SNS. So as you may have noticed, there was a bit of action in the last week. We posted a post on Discover announcing that we plan to create the first SNS soon. And there was a flurry of NNS proposals over the weekend. which, by the way, I was following on Open Chat, on the Open Chat bot that allows me to follow what's going on the NNS. But there was a bit of confusion about what was going on over the weekend. So I'm going to start with a little bit of a recap and an explanation of what was going on. Next slide. So there's actually two subnets involved in the SNS. There's the regular system NNS subnet with, I think there's 10 canisters on there with the governance ledger. And then lastly, there's this 10th canister, which is called the SNS WASM canister. And then there's also an application subnet dedicated for SNSs when they get created. Currently, this is sitting there with a grand total of 0 canisters ready to be populated. So if you go on the next slide, please. If you go onto the Internet Computer Dashboard, you can see these two subnets for yourself, the system NNS subnet and the application SNS subnet there. Next slide. So what was going on over the weekend? These NNS proposals were interacting with the SNS WASM canister. And each of these proposals was there to place an approved SNS WASM within this canister. Next slide. And the net result of all these proposals is there's now an SNS WASM canister sitting there with 6 approved or blessed SNS WASMs inside it. And then briefly, these are a governance canister, a root canister, swap canister, a ledger canister, and 2 canisters that you may not be familiar with, which are the index and the archive. Those are related to the ledger. The index canister is something we've introduced recently, and that allows wallets to very quickly interact with users' balances without having to download the full ledger. Next slide. So what happens when we actually want to create an SNS in the future? To start, there's actually an SNS command line tool that the projects will interact with the SNS WASM canister with. Next slide. This this command line tool will interact with the SNS WASM canister and sends a request to deploy canisters to the application subnet. Next slide. So it's actually the SNS WASM canister that creates the 6 canisters on the SNS subnet and just deploys these approved WASMs. And inside each of these canisters will be the approved WASMs, and it will also initialize the parameters of this new SNS. So at this point, an SNS has been kind of initialized. After the first time we run this, there will actually be 6 canisters on what is currently the empty SNS subnet. Next slide. Oh yeah, sorry. Yes, I was doing a progressive build. I probably didn't need this slide. Next slide. So another change that we introduced recently was a new topic called SNS and Community Fund. And there's 2 important things to know about this new topic. The first is this topic was set up with a default following the same as the governance topic. So every new one will have that has following for governance will also have following for this SNS Community Fund, following the same name neurons. The second thing to know is that this will be used for proposals like a decentralization sale proposal and any future community fund management proposals. Next slide. So back to the Discover post. I'm not going to spend a huge amount of time on this. This post was a heads up that we plan to create the first SNS soon. We're planning, I didn't say this in the post, but we're planning to call this SNS1. And as the post says, there's 4 stages ahead. There's an initialization, and an NS proposal to vote on, a sale, and then the genesis of the actual decentralized SNS DAO. Next slide. So what might you ask is this SNS1 and why are we doing this? I'm not going to reveal all the details of the actual SNS1 today. I'll tell you in a second how you can follow what's going on. But I just wanted to share this kind of the key reasons why we're doing this. So firstly, it's a dress rehearsal, but like a final dress rehearsal, this will actually be a real SNS. And like a real dress rehearsal, we're inviting you to join us in making this a success. But do bear with us a little. It's like a final dress rehearsal. It might not go 100% to plan, so humor us, and we hope it's successful. But bear with us. The second thing we wanted to do was make this fun and engaging, and you'll find out a little bit more in the coming days. And then lastly, I think also importantly, I think we wanted this SNS launch proposal to be an educational journey. The SNS is somewhat complicated, and really only by going through it for the first time can we all understand exactly all of the dynamics of this. So next slide. So where can you look out for more updates? Primarily, we're going to post on Discover on the Internet Computer topic, on District using the DFINITY official account. Please check for the purple check mark. There's a few accounts called DFINITY on District. And lastly, on the forum, we'll post some more technical details as we go through this. Back to you, Jan.
Thank you, Pete. Can't wait to see the SNS1 DAB very soon. The next up is something called deterministic time slicing. It is one of those features that set the internet computer miles apart from any other blockchain. It's also one of those features that are technically very challenging and very tricky, very hard to explain to other people why this is so exciting and so cool, but are really very cool. So Ulan, tell me what this really is.
All right, thank you, Jan. Hi, I'm Ulan from the runtime team, and we are incrementally rolling out this new feature called deterministic time slicing. And the idea behind it is to support long-running messages on the internet computer. In this presentation, I'm going to explain why we need it and how it works, and then show you two examples where it helps. One with canister installation and another with Motoko garbage collection. Can we go to the next slide, please? All right, before jumping into details, let's recap some basic concepts. You probably know that the internet computer executes, in each block executes some messages of canisters. And executing a message means executing the WebAssembly method of that canister. And depending on the method, it could be, the execution could be either short running or long running. And now let's see what happens if execution is long running. Next slide, please. Okay, so if the execution is long running, then this means that this execution is going to delay processing of the next block. And by doing so, it's reducing the block rate. And that is bad for latency and progress of other canisters. Next slide, please. So to ensure steady progress of all canisters, we cannot allow a single execution to run arbitrarily long. So we have to impose a limit on the duration of execution. And we do so by limiting the number of executed instructions. And this means that some messages may fail by running out of instructions, and then the user will see this error message. Next slide, please. So what it all means is that there is this tension or trade-off between the instruction limit and the block rate. So to keep the block rate high, we want to keep the instruction limit low. But if we keep the instruction limit low, then some messages that might want to do useful work, they will fail by running out of instructions. And I'm going to show you two examples where this tension causes the problems. But the goal of the deterministic time slicing is to exactly remove this tension and to allow long-running messages without dropping the block rate. Next slide, please. So how it works, implementation is quite involved technically, but the conceptual idea is simple. To decouple execution from the block rate, we slice the execution into smaller chunks and execute each chunk in a block, right? So in other words, at the end of one block, we pause the execution and then resume it in the next block, and so on. Next slide, please. Now that we know a little bit of the theory, I can show you some examples. The first example is with install and upgrade messages. Canisters usually do a lot of work in these messages because they need to serialize, deserialize objects. And because of that, we have to set quite high instruction limit. If we wouldn't make these instruction limits for install and upgrade high, the canisters would just fail to upgrade, right? And to demonstrate why these high limits are problematic, I constructed this example, like where I have like 10 canisters, each canister doing some heavy number crunching in the install methods. Next slide, please. And when I run these installations on a testnet without deterministic time slicing enabled, then each installation was taking more than a minute, and they were, like as expected, dropping the block rate to almost zero, right? And this was going on for 10 minutes. And if you imagine if there were other canisters on this testnet, then the latency and like user experience for these canisters would be terrible. Next slide, please. Now, running exactly the same test on a testnet with deterministic time slicing enabled, we see that the problem is solved. So these long executions, they are sliced at 800 milliseconds, and that allows to keep the block rate steady at 1 block per second. Next slide, please. I also tested another example, this time with regular update messages, where I have a Motoko canister that tries to allocate some huge array. Next slide, please. Okay, running this on a testnet without deterministic time slicing, the message, this update message that allocates huge array, it fails when it tries to allocate 100 million elements. And it fails because garbage collector kicks in and it runs out of instructions. Next slide, please. Now with deterministic time slicing, this is not a problem, like this test succeeds. And this version of deterministic time slicing is currently being rolled out to all subnets. So in this version, that it increases the instruction limit for regular messages from 5 billion to 10 billion instructions. To support garbage collection of the entire 4 gigabyte heap, we need to increase the limit even more, like to at least 30 billion instructions, and that will happen in like future versions after we get coverage for the current version. Next slide, please. So this brings me kind of to conclusion. So the impact is that impact of the deterministic time slicing is that it solves these long-standing problems, right? So that are related to long-running messages. We have already rolled out the deterministic time slicing for install and upgrade messages to all subnets. Deterministic time slicing for regular update messages is in progress, and there we will gradually increase the instruction limit. We are not currently planning to support deterministic time slicing for queries and heartbeats because they are expected to be fast, but there is discussion going on in forum. Yeah, that's pretty much it. Like engineering-wise, it was a huge effort, and I want to conclude by thanking everyone who contributed and helped. That's all. Back to you, Jan.
Thank you, Olan. I love to see the full potential of this once we've all done all of it. The next one is about reproducible builds. And I guess one of the most, if probably the most important reason for decentralization is to make a system more secure and more resilient. So that means that you build a system in a way such that no single party has control of this whole system, or no single party can mess with the system or make it insecure or bias it, and so on and so forth. And that's, of course, for the internet computer, this means many things, but one thing it means is that nobody should be able to, propose or introduce code that all the replicas run without people noticing this and voting on it. And that is, of course, the reason why when the replicas update their code, this is done by submitting a proposal with that code and then everybody voting on the proposal. And ideally, of course, and I think not only ideally, practically, it would mean that it has to mean that people verify that code to be sure that no malicious actor can get the replicas to run bad code. Now, the question is, how do we do that? And here we have Björn and Marco to tell us more about that.
Yeah, thank you, Jan. So this is Björn from the research team on governance. And I mean, I think, yeah, Jan already mentioned what I mean. The key topic is here, like further sort of the decentralization. And I think in that context, I mean, we already reached like important milestones this year. In the first box on the left side, you see the participation on the governance topic over the course of this year. At the beginning of the year, neurons had to sort of reset their following and choose neurons to follow or vote manually. And participation increased from single digits numbers to close to 50% over the course of a few months, which is like, it's great. In the middle box, we highlight the fact that every neuron can now choose between many different known neurons to follow. We already have 20 registered known neurons, which is a welcome fragmentation of the neuron following setup, and also forces decentralization. And now, like, we want here sort of this now like a call for action where we sort of want to invite people in the community to verify builds. So that would involve, as Jan already said, right, monitoring the development of the code base and then verify that proposed builds actually correspond to the change in the code itself. And then giving that knowledge, also really vote on the election of new replica versions. There are already scripts around, and on the bottom of the slide, you see a link to a tutorial where you can find further details on how to do that. And Marco will give us now a brief demo to see that in practice. Over to you, Marco.
Thank you, Björn. My name is Marco. I'm an engineer in IDX team, and I would like to share my screen. Okay, I think you can see my screen. On the left side, you see the browser with the information regarding verifying releases. On the right side, we have two proposals, basically one for electing new replica binary revision, and the other one is proposal regarding adding archive SNS canister to SNS WASM. So I would like to show you how you verify the artifacts that are part of this proposal, but let's first maybe just check that these proposals exist. So if I go under the releases, okay, I can see the last release. So let me navigate to the proposal. Here is the payload information, which shows where this release artifact can be downloaded from. You have the actual hash of the artifact published. And now, as a neuron, you would want to verify that this is actually indeed the case. So how you do that? You run the script, which is mentioned in the README file. Here I've executed the report check with the mentioned proposal. And what this does, it pulls the artifact that was actually published, and then it starts the build script that actually builds the update image. And then you can navigate to the section where you have listed artifacts with the respective hashes, and here you can see that the hash actually matches with what is published on the proposal. So this is one example. And the second example, if we navigate to the proposal, governments. Here, the proposal regarding this canister actually has the snippet code that you can use there, any neuron can use for verifying the canister. So in my terminal, we can see that I've checked out the respective Git revision and executed the code. So what I want to know now is if I have this artifact with the message with hash digest that ends with 02A03, and here I can see that this matches. So this is how anyone can verify the builds. Here I've included the cloud configuration. So it's important that this is run on Ubuntu 20.04. You can use this to bring up any VM in any cloud provider and then just invoke the relevant scripts, and verification is on the way. That's all from my side. I give the word back to Jan.
Thanks a lot. I'm looking forward to many named neurons and other parties to actually announce that they have verified the replica in the proposal. And if you run into troubles or anything like that, we're also happy to give you a hand towards that, because this is really important to the security of the internet computer. Next up, so we have done a developer experience survey back in September, got a lot of feedback on that, and I'm very happy to say that a result of that is an improvement of Visual Studio Code treatment. Ryan, take it away.
Yeah, thank you. So I'm on the languages team here at DFINITY, and this is just going to quickly show some of the changes that we made as a direct response to the feedback that we received on this survey. So for a bit of background, Motoko is a high-level smart contract language for the internet computer. Visual Studio Code is an extremely popular integrated development environment, and we have an official VS Code IDE extension for Motoko. To directly quote from someone who responded in the developer experience survey, we're really hoping to emphasize reliability and speed over complicated features and really just get the basic UX down. And I hope to kind of show that in this demo. So let's see, do you mind if I share my screen, please? All right, so let's get this started. I'm just going to quickly show how to install this extension for anyone who wants to try. So in the left here in VS Code, there's a little extensions panel. You literally just type in Motoko, and this top option is the official extension. So I'm going to click install, and just like that, everything's all set up. And so I'm going to show some quick little convenience things that we've added recently that have been widely requested. One of them is just a formatter, so you can just immediately magically format this and have just kind of follow the Motoko best practices. Another thing that a lot of people have been requesting is just a quick fix for importing files that you don't have to go and like figure out the path for it. You can just import it. So this is all very standard stuff, and we've just really worked on dialing this in. Another thing that's worth mentioning is it's kind of tricky to show this in the demo, but this totally works completely standalone from DFX or any other software you have on your computer. So you could even use this on Windows with .ws, wherever you want. You don't have to install anything. You don't even need a like dfx.json file. It just kind of works. If it doesn't, I'll have a link to GitHub repository where you can report issues, and we'll try and get a quick turnaround for you. So a couple of features, we have auto-completion for base library Vessel. So yeah, they're all very standard stuff. And this was all made possible by a new language server, which is written in TypeScript, so it's easier to contribute if you're interested in that. And it's also allowed us to get bug fixes out within a day of the being reported, rather than having to wait for the next DFX release. So hopefully this will just, for the developers who are watching this, hopefully this will just encourage you to give feedback, because we can now very quickly respond to this and really prioritize things that a lot of people are requesting. So I'm going to stop sharing my screen. Right, so yeah, so I covered each of these. This is just a quick, just so you can see what we've really focused on. And if you're new to Motoko, I also encourage you to try downloading this extension, because over time we're gradually adding more error messages, and essentially just get suggestions for how to fix errors. So and then on top of that, more documentation in the VS Code extension itself. So we really want to make this really a self-contained experience for learning Motoko. Next slide, please. Yep, this is the final plug for you to go in and download the extension. It literally takes as much time as I was able to show there. So yeah, you could probably do that by the time I finish talking if you want to. And if you have any feedback, We have a GitHub repository. This is all open source, very easy to, you can kind of dig in and see how everything works if you're interested. And yeah, I'm happy to answer questions on there. And I will send some links as well in the chat after this so that you can more easily get to these things. Yeah, thank you. Yeah, that's all.
Thanks a bunch, Ryan. So before you all run away and start coding in Motoko, code up some canisters, let's go to our final demo. I'm very excited about that one because AstroX is one of the teams that have been building on the internet computers actually since the launch. It was the first team in Asia to receive a grant from DFINITY. And also before working on the internet computer, they worked on other blockchains such as Ethereum, Harmony, Sequila, and Polkadot. And of course, it's great to hear that with that background, people decide to move and build on the internet computer. Today, the team is going to present to us like a smart contract wallet solution to get the masses onto the internet computer. Please take it away, show us.
Thank you, Jan, for a great introduction. Hello, I'm Michael from AstroX. We've been building on internet computer for some products and tools for community. And we also won the DFINITY Global Hackathon, and recently we won the Ethereum's Polkadot Hackathon. And before the demo, I want to show you the guys what we are believing. We believe that smart contract will change the software and rule the world. For that, we are upgrading our Me application to Me Plus. So what is Me Plus? Me Plus is a user-owned smart contract canister wallet for multi-chain assets powered by internet computer. We're targeting two problems to solve. One is the mobile first. We're targeting more friendly for emerging market users, for example, Asia, Latin, Africa, etc. And second, we allow users to manage multi-chain assets using ICS canisters without seed phrases. How do we do that? From the left side, we build canisters for users, allow users to control and own these canisters. One of them is the wallet canister. Wallet canister will contain multiple features and modules. One of them, the most importantly, is the TECSA signer. On the other hand, is the Ethereum blockchain. And whenever the user wants to interact with the Ethereum blockchain or Ethereum step, they will be able to sign with the TECSA signer and get the signature back to the mobile app, and then pass the security check, and then broadcast the transaction to the Ethereum blockchain. So let me summarize what Me Plus can do. One is to allow users to manage and switch between blockchains clients, for example, Ethereum, ICP, or any other compatible blockchains. And we can allow users to sign EVM compatible signature with TECSA by wallet canisters. And we can log in to Wallet Connect compatible dApps and directly interacting with all existing dApps on Ethereum smoothly. And then they can send, receive coins and tokens and do smart contract calls on Ethereum or EVM compatible blockchains. So let me do the demo for you guys. Now from the left side is my screen syncing from my iPhone. Now we can see I can have some ICP and ICP NFTs, and we can interact with ICP dApps. But for the multi-chain, I can switch to the Ethereum blockchain. And to this account, I have some ETH on my wallet. So matching the this address, and we open the Ether scan, this address indicating that my account is actually on the Ethereum mainnet. You can see the balance matching. And for the demo, I'm going to show you two types of demo. One of them is to log in. So everyone loves OpenSea. So OpenSea is the most favorite and biggest NFT market in the world. So how do we connect to the OpenSea? So I have my Cell phone enable a QR scanning feature. And I can click on the Wallet Connect. And when the window pops up and I click the connect button, the wallet is connecting in shortly. When I click the profile, I can see my this address and holding some NFT from this address. For the second demo, I can show you how we can interact with Ethereum's blockchain step. If you remember the last R&D call, that Dominic had demonstrate a testnet transaction using the modified version of Uniswap frontend, and I'm gonna show you how to interact with Ethereum's mainnet and do the mainnet transaction. Also, I log in with my Wallet Connect, and I just type in the token I want to swap. For example, I want to swap 1 ETH and calculating the USDC and do the swap and confirm. And a window pop up for my cell phone and confirm the swap. Now, the whole process is coming. The transaction has already been submitted. This process actually signed the transaction from the canister and broadcast to the Ethereum's mainnet. So the transaction is complete. So let me refresh my balance for USDC. Now the transaction is complete and the token swap is success. So let me back to the slide. So what's next for Me Plus? And one, we have to wait for the TECSA GA release. And the second one, we will add enhanced security module. For example, we're adding the 2FA feature from Canister directly. We add black whitelist features for smart contracts. And we will also adding a secure canceling approval for ERC20 tokens, because this is very important for Ethereum's users for security. And three, we will integrate with Launchtrail for Bootstrap interaction for integration for all the canisters. And then we will do the secure audit for all our canister codes. And we should be able to unlock new use cases. For example, one, we can wrap Ethereum's NFTs and trade on IC. And then we can lending and buy now, pay later on IC for NFT assets on Ethereum. And we can also do the in-game microtransactions. So that's very exciting. And this is Ashes Network. And thank you very much.
Wow, this is so cool. Thank you a lot. We have reached the end of our public global R&D. I apologize for the technical difficulties that we have experienced in the beginning. Please join us again on November 23. Hope to see you all there and have a good time until then. Thank you. Goodbye.